Good morning, everyone. It's so wonderful to be here and see so many of you here at the event. I must admit, I'm always a bit embarrassed when they say I'm the SCION inventor, because this has been a journey of 16 years with probably about 100, at least 100 people actively also involved in the design of the system. So maybe, yeah, I was there all the time, but I always want to also give credit to the many, many people who are contributing and continue to contribute to this project. Let me start by explaining the title. And so SCION oftentimes is referred to as a next generation internet. I do like to correct people when they say it's a future internet, because I can say, well, it's already here, right? It's not the future. All of you, unless you lived under a rock for the last couple of years, you've used SCION, okay? So you make money transactions or you pay. Now all your payments, when you pay with a credit card, go over a SCION network. So it's really a next generation network that we can all use today. But as we're using SCION, we also see that there are some additional improvements that can be made. And so I'm going to talk about these. They also have to do something with AI, because already since the beginning, people always asked, well, don't you want to use AI in some way or blockchains in SCION? And we always were looking at these technologies, but so far we didn't see how to achieve very high security and very highly available networks using, for instance, AI technologies, because we do need to have guarantees, and that's what we strive for always in SCION. But now I'm going to talk about new opportunities where we see AI being able to contribute significantly to SCION, and so we call this the next generation internet, or here abbreviated the Next² internet. This really will be a new generation. So I'd like to briefly remind people of the key benefits and how do we get here. So SCION has a lot of benefits, and the main ones are among path transparency that also enables geofencing, so you can make sure your traffic stays in a certain area, but also multipath communication, so you can use several paths simultaneously. And this is really a big deal. We keep mentioning this, and somehow people say, yeah, it's okay, but once you really experience multipath and you experience the power that this gives to you, this very simple concept has just tremendous advantages that once you experience it, you may not want to live without it. So also SCION has tremendous fault resilience and very fast failovers, and this has been not just in theory shown, but also proven in practice. And people observe this, and then, of course, it's really great when you see there's a failure, but you don't even notice it because the system can switch over so fast that it becomes unnoticeable to humans. There's, of course, protection against routing attacks, lots of security in SCION, and also the sovereignty has become an increasingly major deal for SCION with these isolation domains where you can locally define the governance and create strong sovereignty over your networks. So we've seen these features being valuable in sectors that require highly reliable and trusted networks, and we've seen the SSFN as the system that actually brought SCION into the world, and also into other critical infrastructures that have then learned and used the systems that SSFN has created in creating the secure Swiss healthcare network, SSHN, the secure Swiss utility network, of which we're going to hear a lot about today in today's meeting, but also now newly this secure Swiss EFT POS network, where the transactions go across when you pay by credit card at payment terminals. So this is obviously super exciting. And looking from a research perspective, all these applications make use of a technology that translates IP traffic into SCION traffic and back to IP at the other end. So essentially the applications are not aware that SCION exists at this level. And this is obviously great, it works, but we see that a lot of the benefits SCION can offer is unlocked by native applications that really have SCION directly built in. And already last year I've been talking about this because I believe this is going to be a really big deal, once our applications can understand IPv4, IPv6, and SCION simultaneously and optimize across all these technologies. So also last year, I talked about this Sierra network. And in the meantime, the paper was published, you see, with a lot of co-authors, 30 co-authors, some of whom are also here in the audience. And so this is a research and education network that provides native SCION connectivity. For instance, you have this here at ETH. So when you connect to the Wi-Fi here, you essentially can send a SCION packet from your device directly. So we have a demo written in Java, so you can download the jar file onto your system, and your computer, once you execute it, sends a native SCION packet into the world that will not be needing to use BGP to get to the destination. So this is super exciting. Really, you can actually try this out while you're here at ETH. And across the world, we have around 250,000 people that now have native SCION connectivity through this network. So you see different universities and research institutes across the world. And right now, and you say, where's Australia? That's the only continent except Antarctica that doesn't have it yet. And so we're actively working also with an Australian university to make use of SCION. And so this is a part of the SCION network that is, of course, connected to the global production SCION network we see through Switch here. So this is growing very rapidly. Actually, in Brazil, we have currently a lot of universities who also want to connect, and also many other places. So we believe that with some additional changes, we can actually cover 1 million users that then have native SCION connectivity. Okay, so when they then have a SCION-enabled application, that application will be sending native SCION packets to the destination. So this we find super exciting, and we continue to work on this. So, of course, we don't just want to use SCION just to have something else other than IPv4 or IPv6. There's got to be an advantage, right? So we did ping pong experiments with network ping packets, and we see across a 20-day period where we did these measurements, we sent 265 million ping messages, and in a data set that you can publicly access and also look at. And then in the end, you get a graph like this where you can compare IP and SCION across a given round trip time. Essentially, the x-axis shows the latency from the source to destination and back. And then the y-axis shows which proportion of measurements are below this value. So this is referred to as a CDF, cumulative distribution function. Sorry, you're at ETH, so I got to teach something, right? A little bit. So anyway, so at the end, this goes up to 100%, right? So, and essentially, the higher the curve is, the better it is. So you can see the internet is actually better at short distances. So when you want to fetch something from a local CDN, IP is faster in this particular network. But you see, after some point, SCION has much lower latency. And this happens at this particular graph around 130 or so milliseconds round trip time, so roughly at 1,000 kilometers distance. Because of the multipathing, SCION has a lot of different paths and can then, in most cases, beat the internet by quite a large fraction. And so we see at the median value, 50%, the SCION is 7%, roughly 7% lower at that point. And one point I shouldn't get into is it's referred to as a long tail or heavy tail of today's internet. That means essentially there's a fraction of users that get poor performance compared to what they could be obtaining. And it's well known in the internet, this tail can be around 10 to 20%, meaning 10-20% of the users to some further away destination typically gets quite a poor performance. And the multipathing is especially powerful in that sense, because when you have a dozen paths, or even in some cases you're going to see we have 100 different paths available, the fastest path then does not exhibit this high additional latency. Cool. And so we've also measured this in the Sierra network, essentially among all the participants in this ISD 71. And you see, in some cases, there's even one case, even over 100 different path options the source and destination can communicate with each other. And this is super exciting for us because this is a very small network, right? And actually, in the production SCION network that we're using and with all the telcos here, we oftentimes see way over 100 paths, in some cases even over 1,000 paths. And so now you can imagine when you have 100 choices or even just 20, 30, 50 choices from a source to destination, the best of these paths is going to give you really nice properties, or you can optimize across all of these paths. But as a researcher, we looked at this and we said, well, actually, that also can cause an issue because the challenge here is that there are almost too many options, okay? So as a user, you definitely don't want to go through and pick paths, right? That's obviously not going to happen. Also, as a programmer, the programmer should not be burdened having to implement code to deal with all these paths, right? So the system needs to automatically have intelligence and selecting the best path. But not only do we have a lot of path choices, but also SCION offers a lot of opportunities further how these paths are being used. So you can use them in a best effort manner, similar to today's internet, but also there's hidden paths and also a quality of service extension called Hummingbird that then allows you to make reservations on these paths. And there's actually even a lot more that SCION can offer as well beyond these. So essentially, the amount of opportunities kind of explodes, which is a good thing, but also very challenging to deal with, to make use of this in a good way. So there's a major research challenge that we've observed. So how can we actually optimize across this very large number of paths? And or should we even optimize on a per packet basis, right? And should we even say, well, this packet should arrive with these properties, say with a low latency, or this packet should arrive with a low jitter, or that packet should arrive over a high bandwidth link, and so on. So you can even, within one single connection, have different packets make use of different properties. So this is just super exciting. And you can, I hope you can see what kind of improvements this can provide for application and network quality. So, for instance, one example where a system that was built that enables a per packet setting of an arrival deadline is the DMTP system by Tony John at OFGU in Magdeburg. And essentially, for every packet, you can say when it should arrive, what is its deadline, and what is the importance. And the system then automatically optimizes across all the different paths to get the packet to the destination, the latency. So I hope you can see the options are just tremendous. And so we've started looking at this system essentially and say, well, what can we do? So we can have AI come to the rescue. So we're starting a new project to bring SCION to a next generation network, essentially using AI to predict, to collect information about the network, about links, and then using transformer models to predict how the network will behave in the future, and then also disseminate this information. And at the level of the host, also enabling the system to then make sense of these, in some cases, hundreds of paths, to pick the best paths to get to the best possible quality. And could say, well, can't you do this in today's internet? Well, no, right? You cannot have even path control. You only have a single path. So some fragments of this may also be useful in today's internet. But in SCION, everything can then be optimized, including even the path exploration system. And so there's just a lot of super exciting aspects here. So I'm seeing I'm out of time, and people are wondering, how long is Adrian going to speak? So let me calm people down a bit. But yeah, there's also the break afterwards. Maybe that's why they schedule me this way. Because I'm so excited about these these things, this is really next generation networking that we can add to SCION without changing the basis, essentially. Okay, so this is really cool, and so essentially we can also start making use of AI to do multi-criteria path optimization. So already you can use AI type of optimization techniques that we're currently looking at, making sense of these dozens and hundreds of paths to optimize, say, if you have a web traffic or voice over IP or DNS or gaming, to pick the best possible path for that application, or for bandwidth optimization or jitter optimization. But you can also start doing multi-criteria optimization where you can say, I do prefer low latency as long as jitter is also low. So first optimize for jitter in this sense, and so on. And as soon as you have dozens and hundreds of paths, the system can then optimize across all these different metrics and give you the best possible quality of experience for the user. And so we see there are a lot of synergies between AI and SCION. Essentially, SCION can help also AI to optimize distributed training, because again, also there you can optimize for different parameters in the network. We're also providing users with lowest latency links and very high availability links for inference. We're also controlling information disclosure when you have AI systems with very sensitive information, you can use geofencing to make sure this information doesn't go past entities who may want to eavesdrop. And also, with Hummingbird, you can then obtain bandwidth guarantees across the open SCION network. So there's also then AI support for SCION to predict metrics, and people already showed in networking, transformers are not only good at predicting weather, or for systems like ChatGPT, but also networking, they can predict the future behavior of the connection only for a few seconds, but we want to see if we can drive this and also predict the next hour or so the application can then pre-filter paths based on this prediction information. And also, oftentimes, a main challenge is what does the application actually need, right? So again, we don't want to put burden on the programmer so that the programmer has to know how to optimize every packet. That would be far too complicated to write software. So we also want to use AI systems to predict what is the best optimization for which packet for this particular application, right? So that dynamically even the system can learn how to optimize which packet of an application. But at the end, we also need to be careful not to spend too much energy doing all these optimizations, right? We don't want to throw out the baby with the bathwater. And so we're also cognizant of not overdoing all these optimizations, right? In the end, you keep computing and your network is waiting for you to come to a decision. So then that's also not good. So we have to carefully balance, but the SCION internet offers so many opportunities in this space to that then AI can help us to make these kind of decisions. So also last year I talked a fair amount about happy eyeballs and multipath quick and so on. And this I'd like to repeat a bit from last year because it's such an important message. And Jelte van Bommel in our team at NetSec drew this picture here. And I found it really very telling. So essentially IPv4, we're all using it, it's all comfortable. And IPv6 had a lot of work to do, but the work that IPv6 did is now also helping SCION through this strange name, Happy Eyeballs, but it is what it's called. The system that all of you are actually using every day, and also the quick connection that now also offers multipath connectivity. So we have, and I need to speed up a little bit because I'm already way over time. We have sockets in different programming languages that you can SCION enable your application. So this is known, and you only need a small number of lines of code to actually do this. But it takes programmer effort to do that. So what IPv6 has done is that this complexity of switching between IPv4 and IPv6 has to be also dealt with by programmers. And so Apple, in particular, has pushed a library called Happy Eyeballs that makes this task much easier for the user, or for the programmer. So the programmer doesn't have to re-implement this logic. Should I be using IP4 or IPv6 for connectivity? This Happy Eyeballs library will do this for the programmer. And as I mentioned, this is built into all the browsers today, and some programming languages already also are using this as the main way to connect. Now, seeing this, essentially the application doesn't know anymore if it's IP4 or IPv6. We can use the same library and add SCION to it, right? So then, if you're in a SCION-enabled network, such as here at ETH, the system can say, great, I have an IP4 path and I have an IPv6 path, but look, I also have these 20 SCION paths to get to the destination. Why don't I take these also into account to see how I want to connect? And even more so in QUIC, that is now becoming a multipath QUIC library. So many connections, I was going to say the majority, I don't know the exact number, but many of the connections you are performing on the internet are essentially QUIC-based connections. And QUIC is now expanding exactly in the same way, that it can start making use of multiple IPv4 interfaces or multiple IPv6 interfaces at the same time and switch among them as you're communicating. And there as well, adding SCION to this, why would you not use it, right? If you're here at ETH, why would your system want to avoid these? We just did this measurement, the 80 paths, say, to Korea University. When you're fetching this website from Korea University, your system has 81 paths right now, okay, to get to South Korea. So why not use them? Of course, if IP is better, use IP. But in many cases, as we've seen, SCION is going to be faster. So why not use it if it's faster? Right? So getting into these libraries is going to be the game changer for SCION. And so I think this ambition is not, maybe it's a bit crazy, but I think it's still realistic that SCION can become a core connectivity technology next to IP4 and IPv6 that's just there and available on hundreds of millions of devices within the next few years. So essentially, all it takes is an entity to, of course, add this to these libraries. And so we're actively working also in the standardization committees to add SCION to these libraries, which means once it's there, all of your systems are just going to have it. Right? And then when you're on SCION Day the following year, or hopefully you're also going to be in networks that also have SCION connectivity before then, your applications just can use it, right? So why not use it if it's better, right? So we need to work more on the specification, and also the availability of native connectivity needs to improve. I was mentioning we're pushing to 1 million people being covered soon across the world, that then applications that build in SCION into that library, they're going to start seeing traffic when the destination also is SCION enabled. So this also requires the destination server to be SCION enabled, but we're seeing this starting now also here in Switzerland, where the first entities are starting to build SCION into their applications that all of you are going to use. So this is going to be starting in the next couple of months, that even from your phone, you may be seeing some native SCION packets leaving when you're in SCION-enabled networks. So, but this is also a call for help. We can only get there as a whole community, right? We can have the idea and the vision, but we really need all of your help to help pushing this to get along, so that SCION becomes a useful additional technology that gives us better connectivity, more secure connectivity, and in some cases also higher quality of communication. So with that, I also want to make a quick advertisement for some posters that we have downstairs. So we have 3 exciting projects. The Clockwire project with Mark Fry, that talks about secure global clock synchronization with SCION. This is really a big deal. I know it sounds, sometimes clock synchronization, people think this is trivial, but this has been also a multi-year project to provide real global secure time. And we call this sovereign time, which is a contradiction. It's an oxymoron, but I can explain in a break what I mean with sovereign time. Then there's also the SCION browser plugin that we've also shown several times, but we keep improving it, keep working on it. And so François Wirtz is showing this with Brave, Chromium, and Opera browsers. And we also have a Hummingbird poster where Juan Garcia is explaining. Also, Carl Wüst from Misten Labs is here as a co-author of this work. And so you can find them if you want to know more about Hummingbird.